Commanding LaserDisc Players from Retro Computers by Scott Lawrence. This is a LaserDisc. LaserDiscs were a video storage system available from the 1970s through the early 2000s. This talk will be about some interactive uses we can do on them now, as well as some replacements for the expensive parts so we can do this on the cheap. First, let's have a very brief overview of the LaserDisc format. LaserDisc was a playback-only non-recordable 12-inch optical disc format that stored 425 lines standard-definition analog video along with 2 stereo audio tracks. It was primarily used for movies for the home theater, but it also had some industrial and commercial uses such as repeating displays in stores or for interactive museum displays. It could have 30 minutes or 60 minutes per side depending on the format of the video on each side. In the 30-minute mode known as CAV, a movie would have more disc flips, but you could do special effects on the disc on more affordable players, like visible searching, still frames, frame stepping, and so on. This is the mode that was used for industrial uses, as well as for some video games, such as Dragon's Lair and Space Ace from Cinematronics in 1983 and 1984 respectively, Mad Dog McCree from American Laser Games in 1990, Time Traveler from Sega in 1991, and a handful of others. For these applications, the industrial LaserDisc players had fewer front panel options in comparison to home use players. They also included a communications port of some kind and generally were built like tanks, and still run well nowadays. This is mine, a Pioneer CLD V2400 from around 1995. I got it for $75 at Record Archive, and I've seen them for similar amount on eBay, plus shipping of course. They likely cost a ton more than that when they were new. It has a serial port connection on the back that lets you control the player using a standard 4800 baud RS-232 serial connection with plaintext ASCII commands and responses. Mine and many Pioneer units like it from the 80s and 90s all use the same communications protocol. The basic setup consisted of something like this. You would have a computer of some kind, or an arcade board for games like Dragon's Lair, or an Amiga for games like Mad Dog. That computer board could be replaced in the above diagram with a home computer, such as this Apple IIc that is running a BASIC program and changing playback of the movie Roller Coaster. This is an interactive fiction text-based game. It originally ran on an Apple II with a specialized communications interface card, but this version is modified to run using a standard Super Serial card, or the built-in serial port on this Apple IIc. With additional hardware bits, like this video switching interface I threw together, the computer can switch between the output of the player and the output of the computer. The computer side of this was swapped around for the various applications needed. For example, the Doomsday Project from the UK in the 1980s used a BBC microcomputer. The disc media itself was non-recordable, which is why games like Roller Coaster here used an existing movie for the LaserDisc content. One of the things that makes this possible is that in the CAV mode, you have full control of the player down to the frame. Suffice it to say that the player can seek to specific frames very quickly, and you can play forward, reverse, or various speeds. You can see this demonstrated here using the Python script running on my laptop, doing odd playback things to this LaserDisc of Duran Duran music videos. You can also put text on the screen, as you can see in this interactive thing I made for Rochester Maker Faire 2018, running on this Tandy 200 portable computer. It's programmed in BASIC, and it has a simple database of rooms. It uses one side of the 1990s computer graphics LaserDisc title, The Mind's Eye. So this brings us to today. There's a heck of a lot of overhead for getting into messing around with these. You will need a LaserDisc player and a disc to play on it. This can be very prohibitive for someone who just wants to experiment with this. There are already existing hardware player replacement devices such as Dexter for the LaserDisc arcade games, which cost about $400 or more, plus media licensing fees. There's also the Doomsday Project, which recreates LaserDiscs with perfect accuracy. The hardware necessary to capture and play back the media using this project's devices is very expensive and requires terabytes of storage for a single side. I'm working on a Raspberry Pi Zero-based solution that will simulate a LaserDisc player. It will not have the accuracy of the Doomsday Project, but it will also be buildable with the video switch for around $20. My capture solution is an automated QuickTime Firewire Python solution that steps through the disk side frame by frame, saving frames, and then captures the entire side as an audio file. The playback mechanism will be a Qt-based portable application that will run on a Raspberry Pi with composite output. It can also be ported and run on any modern computer instead. This is a just right for enthusiasts solution. It will not be 100% timing accurate, but will be more than good enough, especially at the price point. I'm also working on a few LaserDisc libraries for various systems to make it easier to communicate with players. I have a GitHub repository with starter library code for Tandy 100, 102, and 200 Microsoft Basic, Amiga Basic, and also Python for modern systems, all of which you have seen demonstrated earlier. And I have planned support for HyperCard for classic Macintoshes, as well as for Apple II Basic. The GitHub repo also has the final schematic of the video switcher shown earlier. It will also include the Raspberry Pi and Qt solutions as they are created. Thank you for your time, be well, and enjoy.